Hey Matt, how are you doing? Chat filter all. There we go. Oh, there it is. Hey Jerry, just been a little. Eyes just won't stop bothering me. Going to see the doctor again tomorrow. Try something new. It's got to the point where some nights I just don't go to bed and I just lay in bed all night until I wake up, or where I'm supposed to wake up. So, seems the only nights I can get sleep is when I take Tylenol and Advil before going to bed. And the problem is I can't just keep doing that. Eventually it'll stop working and it'll create its own problems. She's doing okay. I think I finally figured out what the hell's wrong with this. Now that I got the sides to stick properly, but the back is now all loose. I think I have to go back to the original model. I think I screwed up the scaler when I made this original model. So let's bring that into the new one. Hey Joe, how are you doing? Yep, I have plenty of resin printers. Resin's nice for super high detail. The issues are it's messy. And, hang on, where'd that go? There it is. And, it's delicate. Most of your prints are going to be pretty fragile. But then again, most of the prints you would make with resin, they're understandably fragile. You're doing either high detail parts for a model or you're doing a minifig or something like that. And for those things, you'll be fine. But just remember, you need to make sure you fully cure it. So you need to not only do you need to UV cure it, but you really should be heating it while you're UV curing it. A lot of people are finding out that heating it makes a big difference in how well it cures and its durability. It's like a form of tempering, and it's also best to have it painted because if you don't paint it, it'll be continuously exposed to UV light. And even though it should be fully cured, sometimes it's not, especially the cheaper resins. And what will happen is over time it'll continue to shrink as it cures, and eventually it'll crack, and your model will crack. The fix seems to be making sure you fully cure it, and then paint it. Even if it's just like an off-white primer, just something to stop UV light from being able to get to the model. So how big is this? 100. It actually does need to be smaller than that. No problem. This model's been driving me crazy. I think I know what I did wrong. I scaled the model down. This model was originally huge. It was this big. And I scaled it down from this big to this big. And there's one piece that I forgot about, and that was the curvy piece that I used to make the cuts. And I think I scaled it more than 100%, more than 50%, I mean. And so I think the curvy piece went below 0.01 millimeters. And I suspect, it's hard to tell because you can't zoom in that close on Tinkercad. It just doesn't show you that kind of detail. But I suspect that the end of the model isn't square. I suspect it's curved. And so the slicer is selectively deleting parts of the model that are too thin. And that's why, even though I moved it to the correct spacing, my spacing ends up too large. And you get this, where the ribs do not attach to the outer wall. In order to fix that on the sides, for example, on the front, I had to put the part closer than I should have had to. And yet it worked somehow. And I think I'm just compensating for an edge that's too thin. So I'm going back to my original piece here. First of all, this is not. Let's hide this. Break this apart. There it is. There we go. How tall is that? 94.36. And it doesn't go all the way down. Okay. So this needs to be 94.36 scaled, and then I need to align it with this. Align using this as the focus, and bottom there. Now it's properly aligned. Now this should be two pieces. Yes. Okay, that's definitely thicker than 0.01, so I should be able to just take this and move it 0.02 and then join it. And that should be 0.02. And I do see a square edge. Okay. Making sure the edge isn't feathering anywhere. No problem, Norseman. Resin printing is fun. Just remember, use PPE. You know, make sure you're wearing gloves. Try never to touch the resin directly. You know, treat it as, you know, a semi-hazardous chemical. And that includes the alcohol that you use to rinse and wash the parts. Because there is some concern over toxicity. So just be aware. Okay. Control D. Control D. Bring you over here. Why is he doing that? Because he didn't do what I said. I don't know why it didn't do it. Control D. There we go. Okay. How did I do what? Oh, that's why. You're the one who got copied. Multiple placement. Ah, okay. So, a little trick in Tinkercad. Hey, Viper. When you have an object, you can duplicate the object. So, here is your duplicate command. This is also a duplicate and repeat command. So right now I have one square. If I hit Control D, now I have 2 squares, 3 squares, 4 squares. Okay, so you can see now I have 4 squares. Now, this is also a repeat function. So if you perform one single movement or rotation when you Control D, when you duplicate, if you perform more than one, you break the chain. You can only do one. So you have to know what you're going to do in advance. You can perform one translation or one rotation. And if you continue to hit Control D, it'll duplicate and perform the translation or rotation. So for example, if I have one square here, I'm going to hit Control D. And let's say I want another square 10 millimeters away. I hold down the Shift key to restrict myself to the X and Y axis. I drag it sideways, and here it is, negative 44. So let's do it 40 millimeters, negative 40 millimeters. So now that box has been moved 40 millimeters. Don't touch anything. Perform the translation, stop. Now just hit Control D again, and it'll make another box the same distance over. Control D again, it'll make another box, and it'll keep doing that as many times as you want. Now I do the same thing when I make fins on a rocket. So let's say I have a tube, and I want to add a fin to it. Let's say this. Let's design a fin real quick. Let's shrink you down like that. Bring you up like that. Oh, no, that's not what I want. I gotta rotate the other way. I gotta rotate it 45 degrees. 1, 2. There we go. Now, let's make ourselves a little trapezoidal fin for the rocket. That looks good. Now we're going to clip the top of it because it looks nicer when you do that. And you give the fin a little bit of a clipped edge. There we go. Join. So now I have a little fin. Okay. So let's bring this up to 5 millimeters up. Now I do have to center the fin on the rocket somehow. So the first thing I'm going to do is I'm going to align these two this way. So now the fin is going through the center axis of the rocket. Now what I need to do is I need to make sure the fin embeds inside the tube. And let's do 0.1. I just keep going in until, see how the fin's starting to disappear? The last part to go in is going to be this part here. And then go one more for good measure. Okay, so now the fin is fully inside the tube. Now I want 3 of these fins. Now here's you have a problem, because if I try to rotate this, this is what's going to happen. Okay. What I need to do is I need to rotate that fin around the tube. I need to create an array. The problem is Tinkercad doesn't do that. It doesn't know how to. So there's a little cheat you can use. You can rotate multiple objects together, and it will use the dimensional data set of the largest object in the set. So what I need is I need a center point, which I have, because I can find the center point of this tube right there. I create a little ring like this. I make sure the ring is bigger than the radius of the tube, of the fin. So now this ring is the biggest thing in the array. I align this ring with this tube. I select, hold down shift. You see how right now if I touch this, all the parts are going to move relative to each other. And you don't want that because we already have the fin correctly aligned with the tube. So what we're going to do is we're going to tell it, okay, I want to align these parts, but I'm going to hold shift. And I see I get a different set of markers here. That's because I'm telling it, anchor this part. Okay, so now this part will not move, and instead it will move this part to align it. So I align it center and center on X and Y. Now I deselect. Now I have my tube, my fin, and I have this ring. We're going to call it a master ring. What I do is I select both the master ring and the fin. I control D, and now I perform my rotation. We need 120 degrees. So select 1, 2, 0, and there's 120 degrees. And now because I performed a single rotation, I can do it again by simply hitting Control D again. Control D, and there's another rotation. Now I have the 3 fins. And they are correctly rotated 120 degrees around the rocket. I can even go 6 fins, 5 fins, 2 fins, 4 fins, 8 fins. Just take 360 degrees divided by the number of fins you want, and that's how much you have to rotate the first time you do a duplication. So, for example, if I want to do 6 fins, that would be 60 degrees. So I select, Control D, select my rotation here, type in 60, and now I just keep hitting Control D again, 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 and now I have a 6-finned rocket. The trick is you're allowed 1 translation or 1 rotation, and you cannot do anything else in between. If you were to select this, and do this, do that, and then do that again, you broke it. It's not going to work. You get a single translation or a single rotation. So you select your parts, hit Control D, perform your translation or your rotation to whatever precision you need, and then you hit Control D again. And it will repeat, it'll duplicate it again, and it'll perform the rotation or translation again. Now, for this configuration, this is actually square. So if I select these fins, I actually get a square here. Oh, no, I don't. It is still wacky. So if you look here, yeah, see, 58.82 and 66.40. So it's not a symmetrical square, which means I can't rotate that as easily because it's going to create an asymmetric rotation. However, if I select my master ring, you can see it is 101.99 and 101.99, which means I can rotate this as much as I want, and as you can see, nothing changes. However, if I try to rotate the fin set, that's not going to work. So what I have to do is I have to leave this master ring here and make sure this master ring is always centered on this. As long as you do that, you're good. So let's see here. I should have a whole bunch of these. So if we hide this, I can delete my extra rings, bring it back. Now I have 1 ring again. Remember, when you duplicate it, you're duplicating the ring as well. And you want to get rid of your garbage. So you pick the ring, hide it, and then delete all the other ones, and then unhide it. This way you're back to 1 ring again. Otherwise, you end up at like 40 rings by the time you're done everything. And the Tinkercad starts to get slow and grumpy. And now what I want to do is I want to make those 6 fins 1 piece, just to make them easier to manipulate. So now, for example, I can raise and lower it. Change whatever height I want. But there's your little 6-fin rocket. Now, of course, you have to remember, if you want to modify these fins, you can't. You would have to ungroup them, and you'd have to get rid of the other fins. And the fin you want to keep is the one that is currently square on the X or Y axis. So you can see these here, these are not square on the X or Y axis. So you don't want to mess with those. This one here, its face is square with the X or Y axis. So the only two you can mess with is this one and this one. Technically you can mess with the others, but it gets really hard. It's a lot easier if you just get rid of that problem. So I'm going to get rid of the tube, get rid of the fin, delete. So now I'm back to one fin again. So let's say I wanted to make a change. Like I decided this fin's too thick. All right. We're going to make this. Why can't I edit that? Because I'm being dumb. So this fin's too thick. I'm going to thin this fin up like that. Now I do have to recenter it. So I select the tube, align, shift, select the tube, align center. Okay. Make sure none of the fin is sticking out. It's not, where we look good. You can turn this transparent. And what you can do is you can look at the fin and make sure, see how it's shadowed here, how it's darker? That's showing you that this object is penetrating that object. That a part of this object is inside this object. You see when I move it in, more and more of it's inside. So as long as there's no part of this object that is not penetrating, meaning there's no gap. So for example, to show you what I mean, so if I did this, you can see I have penetration here. See, I got the band there, but I don't here. See how it's sticking out? I can see the blue line. That's bad. You don't want that. Here we go. I reset. So I know I have solid penetration. I can see this shadow zone all the way around the fin. Otherwise, you end up with a gap when you go to cut the parts, and then it doesn't print properly. If I need to put ribs on this fin, this is when you do it. You do it when you have a single fin. And when you're done all the edits, like there's no more edits, you're done making the changes to that fin, now you do your duplication and rotation. So Control D, select, let's go to 3 fins again, 120, and Control D again, and I get all 3 fins. Now, I know I have 3 rings here, so I can grab 1, I can grab 2, I can get rid of these 2, and now I know I only have this 1 ring left. So move it to verify it, then hit undo to put it back where it belongs. The reason you do that is in case you have to rotate something. So for example, with 3 fins, this is easy. I need to put a launch lug on this. So that launch lug will be on this face here. But if I needed to rotate this to align the launch lugs, I can do that with the master ring. I just take my fins, shift, unselect the tube, join the fins together. Now the fins are 1 unit. All right, if I need to rotate them, I can't. If I try to rotate these fins, you can watch that they'll see how they're shifting position. See how now this fin's all the way out here with a big giant gap? That's because these are not symmetrical. If you look at the shape, see, 50.34 by 58.12. That's because it's a triangle. Right? So you see this dimension here is bigger than this dimension here. That means I can't just rotate this part. I know, and you know, that these fins... Hey, Joe, thank you. Thank you very much for that. You and I know that the center line these fins should rotate on is this line right here, the center line of this tube. But Tinkercad doesn't know that. And a good way to think of this is to do this. Select the object. See how it creates this square? This square is the shadow. Well, if I put it on here, you'll be able to see it better. See how you can see the shadow of the fins touching the bottom here? Come on. If I select them, see how it creates this square? If you want to know whether or not you could rotate it, just select the corner. If these numbers are identical, you can rotate it. Because the way Tinkercad calculates rotation is to, it does it this way. Oop, I don't want that. the way Tinkercad does its rotation is it draws a line from this corner to this corner, and this corner to this corner, and wherever those lines cross in the middle, that's the center point. And that's the point it rotates the model on. Well, the problem is that center point changes position relative to the walls if the walls aren't symmetrical. If this is, 50 by 50, and I rotate this 90 degrees, it hasn't changed position. And the way you can see that, let's duplicate it. Let's drop it down a little bit. So now we have two squares. Okay? So let's take this square and rotate it this way, 90 degrees. As you can see, they still line up because they're symmetrical. However, if I do this, create a non-symmetrical square, duplicate it, well, now if I rotate this, they don't line up anymore. See? And when you have objects inside of this plane, so you can see the shadow here is my fins, it gets even worse. So if I grab this fin and try to rotate it, watch what happens. See? Because the center point they're rotating around is not the same as the center point the tube is rotating around. However, if I grab the fins and my master ring and rotate it, you can see we get perfect rotation. See? The fins are staying attached to the rocket like they're supposed to. That's because I'm using this master ring here, which has the same center point as the tube, because they're both round, they're both symmetrical, 20 by 20. And this one's whatever it is, 10199, 10199. Doesn't matter what it is as long as it's identical. When you align those two and I fix the position of the tube, now when I rotate the master ring, it's using this outline to perform the rotation instead of using this outline to perform the rotation. It always performs the rotation on a set of parts using the total combined outline of the set parts. And because the master ring has a bigger outline, when you join them, this outline is the same as this outline, because this is the biggest part. So all you have to do is make your master ring the biggest component. So now if a fin sticks out past the master ring, it's going to break it. It's not going to work to a point. But that's it. It's a nice feature. It's a nice way of bending Tinkercad to your will. So the mistake I think I made here is that I shrank this part without rebuilding it, and I made the part too thin. And I think some of the parts were going away. I don't know why I have this here. I have it there for a reason, so I'm leaving it. I want this gone. I need it, but I'm hiding it. So I'm going to try to rebuild this and see if I can not screw it up. Okay. How did I do this? All right, same center point, right? Yeah, same bottom point. So just the top is different. Should be able to just put one on top of here. There it goes. That one needs to be shortened. Take that and this, join them together. All right, that makes that shorter. Okay. No, I need two. Just Control D it. Control D, and then unhinge. There we go. Let's make that one a different color. Come on, stop going to that. Just use the presets. Good. So that needs to stay in position. This needs to move and cut all the way through. So that needs to do that. Okay. I should be able to just delete this now. I'm rude. So I should be able to, let's go and fix this. Why does it insist on doing that? I hate it so much. Why does it keep bringing up this stupid custom thing? I never want to see the custom thing ever in my life. Just go away. Oh, you can't get back to that same color. It's some sort of custom color. I don't care. Okay. This, and this. Join them. All right. Align them with this. Align on this face. Okay, there. Now we have that perfect imprint. Now I should be able to take this and simply shift it. 0.75. Okay. This needs to be a full cut, so we can just put it there. As long as it sticks out and does a full cut. I then should be able to join this and this together into one piece. That should be correct. Okay. Control D, make a copy. Rotate 90 degrees. This doesn't have to be perfect, this has to be close. Then Control D, translate to the next spot. Control D, Control. Why didn't that work? Why did it do that? Like, seriously, why did it do that? I did something wrong. Control D, translate. Control D, there it goes. There's our 5. We know these are aligned, so we can now join them. Stop going to customs. God, I hate that so much. Okay, now we have these. I was going to do a width, but that broke it last time, so we're not going to do that again. Control D. That's not right. I didn't get the last one. Let's do it right. Join. Okay. Let's delete the old one. Now take this and this, align it on this, on the corner. I see the outlines exposed. That's correct. Move it inward. 0.75. Okay. Now we duplicate this and we align it with this corner. Right there. And then translate that one. Negative 0.75. Okay, now those 3 walls should now be correct. Now I still need to do the front one. Control D. Okay, Control D. Why is that selected? That's incorrect. It's repeating my last command. Here to here to here. You guys can see what I'm doing, right? Yes. So Control D again. Translate to the right until it overlaps that. And then Control D, Control D, Control D. It's not exactly correct, but that's okay. I can fix that. Get rid of that. Select that. Join. And what I'll do is I'll just move it a hair. That's close enough. Okay. Now I need to add the face. So if I take this and I align it with this, okay, there, the faces are aligned. Okay. Let's get rid of the top, just to make it clean. And then drop it down just a smidge. Join. Okay. Now we take this, translate it backwards, negative 0.75. Okay, Control D to duplicate it, turn it hollow, and cut it out of this one. Oh, no, I did it backwards. Nope, that didn't work. I don't know why I thought that would work. That was dumb. I need to go this way. So we take this. What did I do wrong? I don't think I did anything wrong. Okay, I just gotta overlap them. This one needs to be solid. This one needs to be a cut. Control D, join this with this, cut. Turn this back to solid and hide it. I take this, make it a cut, and cut this. Good enough. These are on the outside of the model, so I don't care. Although, if I want to clean it up, can I clean it up pretty easily? So I should be able to join this and this. That should work. I should be able to join these two. And cut. There. That should all be correct. Now we just need to turn these transparent to turn them into cut tools. Okay. let's see what that does. Now we take all that crap and join it. Okay. We have our S cut in the back. Then we're opening in the front, which is why we don't need that to go all the way up. Okay. Nothing overlaps, nothing cuts. Let's save it and see what happens. Okay, I printed out like half a dozen of these things, and I keep trying to tweak it and realize now the only right way to fix it is to go back to the model and correct whatever's wrong with it. Because otherwise someone else is going to download it and they're going to try to slice it and it's not going to slice right. And you got to do it right. Oh, it takes forever to download this part. The fit on the lid was good, so I don't have to mess with that. I might tighten it up a tiny bit just as a little snugger. By the way, if you want to add words to this box, that's easy to do as well. So it's one of the reasons why we keep this tool here. Oh, that's not the right width. So one of the reasons we keep this tool here is that it's conformal to the shape of the front of the box. So I can use it to edit the text. So let's say I do this, and I want to add that to the front. Let's see, I want to add that there. What I can do is I can embed this into the model. Duplicate this, turn it into a hole, cut into this. And now when I look at this, you can see it's conformal to the shape of the model. Okay. And now when I take this and join it with this, I get a nice little cut. Take that and we hide it again. There. Now I have a little text added to the front of the box. What you see here is I'm too deep. So I've penetrated to the point where I'm touching my cuts on the inside. So I would have to make this a lot shallower. I just did it this way just to show you what it would look like real quick. But you want to be like 0.1 millimeters in so that you don't interfere with your cuts on the inside. Did I download it? I think you did. Yes. Curvy Box Mini 1. Let's go to show in folder. There it is. Oh, please slice correctly. Oh, I can't do that yet. I gotta remove this. 1, 2, 3. Join them as a group. Center and arrange. And then we just pick the 3 models. That's going to be model 1. Doesn't matter which model you pick. This is just to force the slicer to treat them as independent objects. There we go. Slice, select all. Alright, it's looking good so far. Let's turn on travel moves and retractions. I do not see any spurious travel moves or retractions. Now we look at the walls. See, it's wrong. Why is it wrong again? These should be overlapping. Why isn't it correct? What am I doing wrong? Oh, no, wait a minute. That's the, no, that's not. See, that one's all the way through. Why do I have the spacing? That spacing should not be there. See, this is wrong. These should be overlapping like that, because I made it 0.75. What did I do wrong? It's got to be a setting. Let's just do Ender 3 Pro. All right. Do 1.4, 0.4, vase mode, no top and bottom, 1 wall. The top and bottom are going to break, but that's okay. We only care about the center here. See, now that's correct. So it is a setting. There's a setting in my profile that's broken somewhere. Damn it. See how there's no gap? And see how these overlap just a little bit? That's what it's supposed to look like. So I have a bad setting somewhere in my profile. Let's get rid of this. So it's not the model, it's my profile. Group, reset the configurations. Okay, let's try it again. Let's take a look at it. And we're back to having gaps. See how now there's a big gap there? Okay, so it is something in the profile here. All right, let's focus on the center one here. Oh, shit. How did that happen? Well, that would certainly do it. How the hell did that get reset like that? My nozzle diameter was set to 0.3. Duh. Point four, point four. 0.4. Okay. Let's try that again. That's it. And you know something? That's why this was coming out so thin. I was wondering why this was coming out so paper wispy thin. Like it was almost like it was under extruding. And the only way I could seem to correct it was to crank up the flow rate. I was telling you to print at 0.3. I must have been experimenting with something, and for some reason, at some point, I changed that, and I broke the setting. Yeah, these are all correct now. Now they're overlapping like they should. And this should be a over extrusion, 1.05. Oh man, I cannot believe all this time is this stupid setting that I screwed up. Okay. One number. That's how easy it is to mess that up, huh? There it is. Nope, that's not it. This is it right here. Oh, I feel so dumb. All that, literally a week's worth of printing broken because I screwed up one setting. One freaking setting. Save the factory file. Save the G code. We're good to go again. One stupid freaking setting. All it was in this process, for some reason, I had set this to 0.3 and 0.3. Well, at least that's fixed now. Yeah, I wanted to print out that sample body tube that I designed. Where is it? I'll just re-download it. No. I think it's this one. Oh, man. Yeah, there it is. Export. Fabulous Kirkin. Downloads. Let's bring you up. New. And under 3.41.4. We can go to 0.3. Since it's all vertical, no overhangs. Okay. downloads. Okay. Yeah, it looks good. Yeah, that looks good. That little straight section should cause that to fuse. This should create some nice fusion. Although that's a lot of wasted material I really don't need. But we're going to print it anyway because I want to try a couple different shapes. Tube, triangle. Okay. Let's switch back to this. Let's try to make a new shape. I really should be using my default tube size for this. Although it doesn't matter because I have to use custom sleeves anyway. It's an 80mm tube, it's fine. Okay. Triangle vase mode tube. We're doing 200 by 80. New design. Okay. 80 by 80 by 200. Maximum number of sides. How big was my center punch? Tube, diamond. Let's see here. I need to see the other one. Nope. And 60mm. Okay. Go back to diamond. Okay. Max the number of sides. 200. 60. 60. Okay. Line. Cut. Alright, there's my base tube. Let's copy that so I don't have to keep Control D, so I don't have to keep doing this over and over again. I can just bring that with me when I go. Okay. So if we are 80, and we subtract 60, that's 20, that's 10. So 10mm wall. So we're going to go diamond, and then we're going to make it 10mm. Okay, that's the maximum. Now I have to actually make that smaller. Okay, we're going to want to do this. 10. Really? Really? see anything? Nope. Okay. Oh, it's always in the way. 10, 0.02. So this needs to be 10. Not 10. This needs to be it needs to be 10, and then I have to shift it. Okay. So 10. Which means this needs to be more like, I don't know, 9? 4, 8, 12, 16, 1.6 millimeters. So let's make it 2 millimeter difference, 8. Make that back to 10. And then these two need to join together. Okay. Excuse me, you asshole. Why would you do that? Okay, there is our cut tool. That's going to give us our diamond pattern. Okay. So that gives us our diamond pattern. Now we need a master ring. Technically we don't, but we're going to have one anyway. Line center on this piece. Grab you and you. Control D. We're going to rotate that much. There we go. Alright. Now get rid of my extra ring, so I'm going to hide one, select the rest, and then restore it. Oh, no, 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 no. That's not going to work. Dumb, 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 dumb. I got to move this. I want to keep the diamond centered. So we take this, we bring it into two pieces. Let's change the colors so that we're bicolor. Alright, so this one's going to need a duplicate. Control D. Let's make this 12 so it protrudes outside. We will then hide this. Hide. Then we'll take this and we're going to translate it. Negative 0.75, which gives us that. This now joins with this. Turn it transparent. Join it with the master ring. Duplicate. Rotate one 15 degree, 22 degree tick. And duplicate it all the way around. Restore our little extra cut. Turn that transparent. Let's hide one. Get rid of the rest. All right. That should do it. Join. Okay, there's the diamond shape. That should actually be really strong. And then we also want to grab the other piece, triangle. So we're going to copy this, go back to our diamond. Where the triangle one is good is if you want a really strong external skin, because that's going to give you a double thickness external skin. This is going to give you a thin external skin, but with lots of interior structure. Alright, split you. Control D. We're going to align you with you. Okay. Okay. Let's get rid of mode. Let's just call it TV. Tube vase. TV dash diamond. And dash smooth. Export. Let's call it Coro for corrugated. Export STL. That's smooth and Coro. Okay. Now, I also want to try making I would like to eventually try to make these join together. So have these touch. I don't know how to do that precisely, though. I can eyeball it. Well, I can do it here. Can't I? No, I can't. Because I need to adjust that one, too. So let's Control D this, put it over here, and let's break this apart again. Let's just get rid of these for now. Okay. Okay. So what I need to do is break that apart. How do I want to do this? Let's go 20. And then let's recenter it on this one. Okay. Now if we take this, Control D it with this. Okay, so the overlap is too much. So 20 is too much. Let's go to 15. And again, center it on this. Control D, 15. Okay, we have a slight overlap. Nope, I can't do that. That might work like that, but just for the hell of it, let's try it. I mean, worst it could do is not work, right? Yeah, this one and this one. Join. Control D with the ring. One tick. Oop, too many. I also forgot to make it clear. That's going to be a tricky one. Select them all except for this and this. Make them all transparent. There we go. But I don't know. They need the touch. Nope, that's broken. That won't work at all. Nope, that won't work. So let's resize this to 13, 14. Oop, too many. I got duplicates. Oh, I'm missing something. Where's my pieces? There it is. Break it apart. Let's go 13. Align. Okay. Am I missing something? Oh. Hello, Caro. Why don't I see you in here? I hate when it does that. Or it doesn't show me everything. Chat all. There we go. How you doing, Zero? You having fun today? Okay, join these together. I hate the red. I'm doing pretty good. I do my best to keep my victims happy. Okay, now I need to join these together. I think it might be pretty simple. Oh, come on, give me my dimensions. Why are you gonna mess with me? What are you doing? Where's my goddamn dimensions? Why are you on that face? I was just picking the wrong one. Oh, it's all the way out there. Why has it got to be all the way out here? Okay, take this and this. Damn. That is not what I wanted. But I think I know how to get what I want. Yeah, I think I know how to get it. Thank you. So 1.25 should put me exactly in the middle. Okay. And now let's shove this. Are you going to give me my little arrow all the way up here? Why is it all the way up there? Sometimes Tinkercad really does not like messing with tiny things. I know what I need to do. Control D, rotate 90 degrees. Needs to be 0.8. Why do you go away? I didn't ask you to go away. 0.75. Okay. Line here. We take this and this. Align it on this. Center. Do this and this. Cut. There. That should do that. Then we bring this out. Until we get this. Okay. Two. Okay. Put this back down here. We hide this. Nope. I don't want to do that. Hide it. Okay. Bring everything back. Let's hide one of you. Let's hide you. Delete all of you. Okay. Bring you up to the top so I can see you. Take all this, make it transparent. Bring back our tools. All right, now we take this, Control D, join it with this. Jesus Christ. And then we rotate around. There. That should do it. That's going to be a very complicated print, but it should be stupidly strong. So hide one of you, delete the rest, join this all together. There we go. Now these should be close enough to merge. So they should fuse together. It's going to be heavy, but it'll be ridiculously strong too. Let's call this diamond 2. All right, let's see how these slice. Let's Control D and join that with this as well. That little corrugation on the outside will add strength. Okay, we're going to call this one Coro. Export, STL, and to Coro. Okay. All right, let's see how they slice. Let's do the. Let's we do this. I already did that one, didn't I? Tube triangle, yes. Okay. Let's try this one. That looks good. $8 hours, 85 grams. I don't see any imperfections. That looks good. Let's save that one. TV Diamond Smooth. Let's do SM for smooth. Okay, remove. Do the next one. Let's do the corrugated. Next one, diamond. Did it work right? Yes, it did. Look at that. Nice. Yes, these are all in vase mode. I figured out a trick to make complex multi-surface models like this, all in vase mode. So you can see, this is the one cut that goes to the outside wall. And the way this will work is it'll print the outside, and then it'll come in here, it'll come over here, over here, over here, around the inside here. It'll come in here and do this one. Oop. And then it'll come over here and do this one all the way around until it gets all the way back to here again. And then it'll come around here and go outside and do the outside of the model. And these gaps here are designed so that that's the minimum gap the slicer will allow, which is 0.5 less than 2 times the nozzle diameter. So I'm printing with a 0.4 millimeter nozzle. So this is a 0.8 millimeter gap that I shrank to 0.75. That's within tolerance. The slicer will permit that. And the result is these points here fuse together. The plastic is close enough that the plastic fuses together. So you have an integrated manifold structure that's all vase mode. That is going to be one bitching strong part. And then this one, I added even more strengthening by corrugating the outside. So I put these little divots on the outside to corrugate it. So now this vase mode print has 4 walls, an internal 3-dimensional structure, well, 2-dimensional structure. These points are all fused together, and corrugation on the outside to beef up the skin of the model a little bit too. Now this won't be compatible with my threaded parts. There might be a way to make it compatible with that later, but for now I want to see, you know, if I want to 3D print an ultra lightweight rocket that is just ridiculously strong for its mass. This should do it. Okay, this here should be the strongest one, and you can go a little more elegant if you want. So I could use ovals for this. Actually, let's do. I want to see if there's a strength and a mass difference. So I added all this structure added another 13 grams to a 200 millimeter tube. That's actually a lot. It's not horrible, but it's not exactly lightweight. But this is for mid power, high power rocket. So this is for it's a 3-inch tube for a stronger rocket. Let's see. How do I want to do this? Let's try making one with a circle. So Control D. We will save you over here. Take you, detach. We don't need you for now. We can just get rid of you. Detach again. If we hide you, grab all of you. No, I don't want to do that. Wait a minute. Yeah, actually I do. Let's take all of you. And we want to save you, you, and you. There we go. Bring back all my parts. Now what I want to do is I want to separate that again. And I want to replace this with an oval. So a 13 by 8 oval. Eight by 13. I should be able to make that a drop-in replacement. So I should be able to just drop that bad boy right in there. Let's make you a little taller and join with you on you. Just because curves look nicer. Okay, that should work. Let's change your color to you. Make you a little taller. Okay. Let's make you a different color. There. So I should be able to take this, this, and this. Join them together. Make them transparent. Make you transparent. Take you and you. Control D. I should be able to do my 22.5-degree rotation. And that should all line up. And yes, sirree, Bob, it does. All right. Again, hide one of you. Delete all the excess. Take this. Join it all together. This is probably going to use even more material, but this will look pretty. I suspect the diamond will be stronger. I'm not sure what will be stronger. Oh, that looks cool. This is in the wrong spot, but that's okay. As long as the spacing is correct, that's really all that matters. We have one all the way through, yes. All right. Let's go oval. Oh, this is oval. export. All right. Control D. Okay. This one's the corrugations. This shouldn't be taking this long. It wasn't a complex operation. There it goes. All right, there is the pattern with the corrugations. You know, in theory, I might be able to design this and get rid of this smooth inner wall and have this here be the inner wall. That'd be really hard to do, but I'd have to think on how to do that. I don't know exactly how I would do that right now. Oval-CO for corrugated. Okay. Remove. Let's try oval. Really? That's how you're going to do that? Oh, I think these would fuse no matter what. Okay. Let's make sure we didn't break anything. Basically, to test if we break anything, just watch this pencil. If that pencil moves at all, then you got to look at that area. See how it's staying in the same spot? That means there's no change layer to layer. That's good. Okay. And that is 101.79 grams. So it definitely does make it heavier. That made it an additional 4 grams heavier. Now, ideally, the way you want to print these is you would custom make a printer. So you would build like an Ender 3 with a 1000 millimeter vertical Z-axis. That way you could print a 1 meter single piece tube. That would be the ideal way to do this. Okay. That looks good. Did I already export this? No. Damn it, that looks good. Now, is there any way I know how the tool, hey red light, I know how the tool path would work, but how do I create a model that would create that tool path? I'll have to think about that. I don't know how I would model it. Okay, as best I can be. I'm having some pretty severe sleep deprivation issues because of my eyes. And I'm actually going to, I've been waiting a month for a doctor's appointment, but I'm going to see the doctor tomorrow. Hopefully, I don't know, figure something out. Okay, that should be it. These won't be quite as elegant as my, threaded together rockets, but they should be stupidly strong. I mean, this is basically a 4-wall vase mode with integrated structure. And the structures all attach and connect. Theoretically, you could even you could do some really weird things with this. This might actually be, yeah, we're going to do this. Yeah, we're doing this. I just got an idea. Yep. I just got to figure out how to do it. Control D. Split. Split. Let's hide you. Let's get rid of all of you. Okay. There's our base components. Okay. I want to put a word in here. Hello, Irek from Poland. How are you doing? I want to spell a word. Yeah, I really badly want to spell a word just because I think that'd be fun as all hell. Get rid of the oval and get rid of the connector. How pissed off is this slicer going to get at me for doing this? Let's go NAR. Yep, let's go simple letters like that. Can I even do letters this small? Like, will it even tolerate that? Is there any way to curve it? I guess I would have to do 3 separate letters and rotate them manually. Let's see here. Well, that's the right size. How do I want to do this? So I have to do one letter at a time. Otherwise it won't be centered. Is there a curve text? I don't see an option here on how to curve it. I got height, bevel, and segments. Where's the curve text option? Search. Yes, curved. Curved words. NAR. That works. And the arc is the opposite of what I want, though. There we go. Let's go 20. Okay. Let's rotate 90 degrees. Let's get rid of you. Okay. The letters aren't lining up right. See, this letter's too high, this letter's too low. Why is it doing that? Yeah, I'm better off doing it myself, I think. Yeah, that's just fugly. Okay. First, is this the font I want to use? I definitely need to use that. Okay. Yeah, that was too finicky. So now I need an entry and an exit point. Which is not a problem. But I first have to make the letters. Okay. That looks pretty good for spacing. Okay, now Control D, Control D. So one of these needs to be an A. And one of these needs to be an R. Then I need to select all of them. N, A, R. Align on this piece here. Oh, I can't do that. Hey, don't turn off on me. Let's select the letters. I guess I can do this. So center U. Center U. And center U. Okay, now the letters are centered. The A needs to stay there. The other two letters need to move. Okay. Are you serious? Oh, Jesus Christ. I need to see the goddamn number. So, 11 degrees is enough? Looks like it. R and U. And go, come on, 11 degrees this way. Okay, there's the logo. My concern is that this is smaller than the nozzle size, and it won't be able to print it. I don't have to do NAR all the way around. I could just do it once or twice for effect. Okay, so let's take... I think these two I need to split. I think I need to split them. And that needs to be a 0.75 millimeter gap. Is there enough room there for a 0.75 millimeter gap? Okay. Let's Control D this. Let's make it a different color. Let's raise it up. Okay. Bring it down here. Oh yeah, that's way too big. Okay. Oh, come on. 0.75. That's doable. Okay, you and you. Align on you. Let's Control DU. Transparent. Join. Take you and you. Where the hell's my rotation? It's all the way over there. Why is it over there? Oh, I hate when it does dumb shit like that. That'll work. Yes, that will work. Hello, join. Okay. Good. Now the letters are properly broken up. N doesn't need it because N doesn't have a crossbar. Okay. So now I need custom cuts. A can join at the top. And then this external cut is only needed one time. So you can cut in, draw the outside, draw the inside, go back out again. So I really need a second one out here so that I can connect the letters with the outside skin. If I don't connect the letters with the outside skin, it won't be strong. So what I need to do is Control D this, lift it up a little bit. Let's change this to yellow. Okay. And this. Where the hell is my grab? Why is it down here now? Okay. I need to do that. Okay. We need to shrink this down. Like this. Like that. And then we need to shrink this one down. I need my grab bars. Where the fuck are my grab bars? There we go. Shrink this one down like that. I'll have to move this somewhere else. No, I'll fix that later. Okay. Now I need to do the same thing for the other locations. So Control D. bring you over to there. Control D that. I need to bring you over to there. There we go. That connects the letters with the outside wall. I need to do something similar with this piece. Control D. And we need to do it there. There it is. Okay. Okay. Oh, the A needs another one. Okay. Control D. That connects that one. Control D. And that connects that one. Okay. Now I need one more. For the N. Control D. There. Okay, so the N, in, over here, touch, exit. A, over here, over around here, exit. R, in here, around, out. Okay, they're all correct. Now I need to take this, and this, and stretch that shit out. Okay. They are the correct length. They are all the correct length. Okay. Oh, man. That looks pretty good. Now I should be able to take this and this, rotate it 90 degrees, just to get it away from the letters. Let's hide this for now. Let's grab all of this, join that together into one big honkin' mess. Not what I wanted. Okay. There. Now I should be able to take this. Well, let's take this and rotate it 45. So I can do 4 NAR logos. Control D. Jesus Christ. Okay, just one. Control D. Select. Let's go 90. Okay. Now I got 4 NAR logos around the tube. I have my full cut through. So I should be able to take this whole thing, rotate it 45. Okay. I should be able to take this, Control D. Do that. Not what I wanted, but it's good enough. You want to be an asshole? Fine, you can be an asshole. Okay, do that. This needs to go this way. Negative 0.75. Okay. Now we need to add our regular ribs. Control D. Control D. Let's go one rotation. And one rotation. Okay. Take this one, this one, this one. We make it a set. We Control D. Join with the master ring. Rotate 90 degrees. Duplicate, duplicate. There. We now have a standard wedge tube with the NAR logo built into the design. It's going to be stupid heavy. It won't really add too much structure, but it'll look really freaking cool. Theoretically, you could even put your NAR number in there, but that's a lot of work. Let's see how this works. There we go. I have a feeling these letters are too small. Maybe not. It's going to be close. It's going to be real close as to whether or not those letters are too small to viably print. Making a bigger tube, this would be a lot easier if I scaled this up. Okay. I want to see how this slices. If it slices at all, it might not slice properly. Oh, crap. I made the mastering part of the merge. And scaling this one up would actually be pretty easy, because all I gotta do is adjust these when I scale it up. Okay. Export. Will it slice or will it puke? Oh, no shit. It worked. Did that really work? No shit, it worked. Okay, that's cool. That's really freaking cool. Yeah, we're definitely printing that. You know, I might have to change this. I might have to make put T3DP on these two sides and NAR on these two sides. So today's 3D print and the NAR. This is not Rifle Association. This is Association of Rocketry. That came out cool. Oh, I'm so looking forward to printing that. That's just badass. You know, if I did the NAR logo 5... Oh, look how heavy it is. 120 grams! Woo! It's the heaviest one yet. Oh, that's cool. Boy, is that a lot of work to do. But the result is so cool, though. You could put an entire word, sentence around there if you were willing to put in all the work to do it, because that's a lot of work. Because remember, you have to put in these little nubs to connect the inside and outside. Yeah, NAR's heavy. This is a lot of filament to make this. Each of these is equivalent to probably 3 of these, because this is just in out, while this is over and around and around and around. Actually, 1, 2, 3, 4. Each of these is equivalent to 4 of these, close, almost 4 of these. So these are this one is 1, 2, 3, 4. This one is 1, 2, 3, 4, 5. The N is the heaviest. So this is like adding a crap ton of extra ribs. There is a way around that. I don't have to have these so close. Let's make 2 versions, because this version does look pretty cool. I like that version. Yeah, it looks crystal clear. Although you'll only see it from the end. You won't see it from the side. So this ought to be interesting. So let's get rid of these groups, since I don't think I'm going to need them. Oh, really? Pomegranates are good. Okay. Let's get rid of you. Get rid of you. Okay. So, let's get rid of these. Okay. We're back to our default here. Now, this should be pretty easy. Yes, I can do this. So this, and this. Join. Let's make you green, and then transparent. This, join. Let's make that not transparent. You'll see why in a moment. Let's make you blue. This, and this. Let's join, and yellow is fine. Okay, so now we have our 3. Now what I can do is I can spread these out more. These don't have to be clumped together this tight. So take this and this. Now I did 11 degrees. So I should be able to do it another 11 degrees. Where the hell's the number? God damn it, where's the goddamn number? Has it got to be all the way out there? Does it really have to be all the way out there? So 1.25. Let me take this one and this one. Negative 1.25. There. NAR. And now I don't need the extra ribs at all. Come on. NAR. Join. Transparent. Control D. With this one. 90 degrees. There. That should be strong enough without any additional ribs. I might want a rib in between each of these. I probably do want a rib in between each of those. Control D. There. Yeah, that's stronger. Okay, so hide one, delete the rest. Yeah, this might actually be better. That little bit of spacing works good. Yeah, I think I like that. R-2. There we go. We knocked 15 grams off of it. That's 15 grams lighter. And that is going to be plenty strong. I can also add the corrugations, but I got to make sure the corrugations don't go where we don't want them to. But yeah, that works, and that looks good. Yeah, that looks great. I think it looks better spaced. I'll save both, but I think it looks better spaced. And it's lighter. Now, I could probably space them a little bit more. If I bring this out to just like another 5 degrees and this out another 5 degrees, I might be able to get rid of all these. And I can get rid of this by simply making one of these the cut through. That's better than 119.89. We knocked 15 grams off of it. But I also like having each NAR boxed in so you can clearly see NAR, NAR, NAR. I like that. We're going to print those. That's pretty cool. Now I should, let's say I want to scale this up. I can just double it. I can double it and print it with a 0.8 millimeter nozzle. Yeah, that's easy. Let's eject this and get that going too. USB, eject. Alright. That one is ready. Let's do this one. Yeah, it's about 105 grams. Okay, I already did that one. Okay. So let's do the NAR one. I like the NAR one. Oop, no, we don't have to do that. What we need to do is change the printer to this one. Yes. So 1 millimeter, 1.0, 1.0. No, we're going to do 0.8. 0.8. And then we're going to do layers. I bet you I can get away with 0.6. 6. .6 phase mode 1. Let's go 105. I like to over extrude a little bit, and that doesn't matter. Okay, so we should be able to double this to 160 and 160. Oh, 160, which is 400 tall, which the printer can do. No, it doesn't. Oh no, this is a 3.3. This is a 3.34. Yeah. What's the problem? Three, 3, 4. What's the problem? Maybe it just doesn't like it being that tall. Let's do 390. There, now it's not yelling at me. I just knocked 10 millimeters off, just to be safe. Oh no, I'm printing directly on the aluminum plate. I can go all the way up. Yeah. Okay. Ooh, that's going to be a strong-ass tube. Now, this one I should probably put the corrugations on. But I don't want to. Looks clean. Let's make sure we don't have any dip. Oh, yeah. We do not want to start there. No. That's just dumb. Let's start at 0, 0. That's a real dumb start point. There we go. I want it to start on the outer wall. I don't want it to start in the middle there. That is, ooh, almost 900 grams. But this is a 160 millimeter tube, and you can build one hell of a rocket with this tube. Like, this would be a very strong rocket. I think I want to print one, though. Well, yeah, this would be a 7 or 8 foot rocket. This is a big bird. And I do have enough plastic to print this. I do have 10 kilograms of PETG. One of the vendors gave me. And yellow and blue would look nice, too. I'd have to design a motor mount and everything for it, but that's no big deal. I can even still make it threaded by gluing a thread insert into this that the motor mount would then thread into. That would not be that difficult. And instead of trying to thread these together, just glue them together, create a sleeve to join them together. The sleeve could be threaded. I could glue threaded inserts into it. But that might be a hassle. Maybe have a single threaded joint in the middle to make it break down a little easier. Yeah, I can usually get it for about $11 a kilo. Let me check. PETG. There's King Rune for $12.59, Naga for $15, Creality for $12.99, Eligoo for $12.99, Sunlu $13.49. That's 14 a piece for a 2-pack, 13 a piece. I can usually find one for 11. Everyone for 12. Although I'll pay an extra $1 to get a cardboard spool just to have less plastic to throw away. Now, for a rocket like this, transparent would be a lot of fun. There's some gold. But transparents like this are a lot of fun when you're building a rocket that big. These transition rolls are really nice, but it's difficult when you have multiple pieces. Because if the next roll doesn't start at where the other roll left off, it gets weird. That's a little more expensive, but I like that color. Well, there, that's not that bad. That's only $10.25 a roll. Ooh. Hell yeah. Where's my... Let's add that to Pet G. Where's my link share? Where's my link share? Why the hell don't I have a link option here? Oh, I can do it this here. Next. I forgot it's different on here. That is a good deal. $10.25 a roll. Nice. I like Yoyi's filament, but their PETG is a bit on the brittle side. I'm not a super big fan of the brittle. Ranky, it's beautiful, but I had problems with fusion, and for some reason only with this filament. So something about this filament, my seams weren't fusing properly, and I'm not entirely sure why. This is good stuff, but it's so expensive. I think this is that company I used to buy from, and they just changed names. But this purple is so pretty. I'd love to make this whole thing out of purple, but that would be an expensive rocket. You're looking at what, $25 a kilo, and a kilo per segment. A 1.2 meter rocket is going to cost, well, $100, $125. What is that color? Is that transparent? Yeah. Yeah, that's fake. There's no way that's an actual print. That's CGI. That's not a print. There is no such thing as a filament printed model that is that optically clear. Not. Why would you use a fake? Don't do that. Because there's no way in hell you're ever going to get a print that looks like that. No way. I wonder if it's actually tougher. Yeah. Well, what it is, they're lazy. It's not so much they like fake, it's they're lazy. Um, in order to put a model there, they would have to go get a model, print it, and wait for the print to get done to put it on the desk in front of the picture. It's easier just to grab an image and make it transparent. That's not them. That's not really them being scammy. That's them being lazy. Whoever made that, they were just lazy. Yeah, I don't think I'm going to find better than $10.25. This is beautiful. It's brittle. Sadly, it's just truth. It's a brittle plastic, but it's the result is beautiful. PCTG. Oh, nice. Yeah, I saw eSun, but I found cheaper. Right now the best price is $10.25 a roll. PCTG. Ooh, expensive. 3D Fuel is good stuff, though. I like 3D Fuel. That's PETG. Why the hell are you showing it to me? See, I hate that. I hate when they do that. Yeah, it's way too expensive. That's $130 to make the rocket. Wow, that's expensive. Yeah, that's how much they charge. So they're using the valid list price. Yeah, and 3D Fuel makes good filament. Yeah, see, $45. That is their normal price, so they're not ripping you on the price. Let's see. Well, hell yeah, and plus it's if you have a YouTube channel where you make any money at all, it's a write off. That's a business expense at $45. eSun, PETG, $16 a kilo. So the eSuns, I figured the eSun would be pretty expensive. They are good plastic though. Yeah, 3D Fuel is fantastic. I love 3D Fuel, especially their autumn orange. Oh, I love the autumn orange. God, the autumn orange is great. Now you know what's weird is I could probably get away with printing this in PLA as long as I use a light color because I'm using a 0.8 millimeter extrusion. I might actually be able to get away with printing this in PLA. The advantage being I can use cheaper plastics and have more color options. Yeah, definitely going to print this. Did I export this already? No, I didn't. TV NAR 2. Okay. Yeah, I definitely like this. I'm really surprised how nice that came out. That really turned out nice. I'm too lazy to do it now, but I'm going to do a T3DP one later. Very, very nice. Yeah, this is gonna be a nice print. Hey, DeWitt. Silver PETG might be interesting at some point, just because it gives you that classic sci-fi rocket look. You know? Although I wonder if I can add the corrugations. Let's see what would happen if I tried to add the corrugations. Let's see. Control D. Holy crap, no conflict. Look at that, it doesn't interfere. Oh, we're doing that too. I wasn't sure that was going to work. But I don't see a conflict anywhere. That'll beef it up a little bit too. R2CO for corrugated. Okay. Let's keep the same settings. R2CO 160 399 center. NAR, N-A-R. National Association of Rocketry. I could probably get the NAR logo in there too. That might not be that hard. I didn't think of that. There we go. Nah. Well, I could do it if I got rid of the... well, there's my pictures. I printed those. If I got rid of the NAR down here and just made it this triangle with this in the middle, I could do that. Let's save it. I'll mess with it later. But yeah, if I get rid of the line, get rid of the NAR, well, the line would connect it, so I'd keep the line. Yeah, but if I got rid of this NAR, although with the 1mm print, that's a 20mm wall thickness, I could probably keep it. Although my biggest issue is that when I double the size of this, I double the wall thickness, and that's kind of dumb. There's really no reason to double the wall thickness to 20mm. So I'd probably want to redo it to keep the wall 10mm thick. But that would be, I'd have to basically design it from scratch. I'd have to redo this whole thing from scratch. And that would be a pain. Well, there is a way around that, sort of. Because I kept these on the proper radials. These are 11.25 degrees apart. I can rotate this to the correct value. So I could do this. Definitely not what I wanted to do. There we go. So now I could scale up the tube without scaling up the letters, and then move the letter directly outwards until it's in the proper position again. I could do that. And then rotate 11.25 degrees, do the R, rotate negative 22.5 degrees, do the N, and I wouldn't have to design it from scratch. But will they print at the smaller size with the 0.8mm nozzle? Because that would greatly reduce the scale here. Because that's a really thick wall. That's a 20mm thick wall. And there's no reason to have a nearly 1-inch thick wall. Although, how much would that actually reduce the size? Probably not by as much as I think. I might try it though, just to see if I can lighten it up a little bit. Because honestly, there's no with a 0.8mm extrusion, there's no reason for this to be. You too, Ciro. Thanks for joining in. There's no reason for this to be 20mm thick. That's awfully thick. Although if I want to go with like a K, it certainly wouldn't hurt to have a thick wall. It's certainly not going to hurt. Who the hell is that? Hmm. All right, I'm gonna go. I'm gonna I'm gonna print a small section of this. Now let's see. I want to print a little piece of this. So let's print I don't know, 50 millimeters. Yeah, that's enough. Just as a sample. Just to see how it looks, how strong it is. CO-S for sample. Yeah, I'm going to print a little sample of this, see how it comes out. Make sure the 0.8 extrusion with the 1mm nozzle fuses. Before I go blowing a whole kilogram on a tube just to have to throw it away. That would suck. Yeah, the corrugations are right in between. That'll help stiffen up the outer wall. Nice. Okay. And what's nice is I can upload a little model of this, just 50 millimeters tall, and then I could just tell the user, lengthen it to whatever, however long you want. You know, however long your print volume is. You know, just all you have to do is unlink uniform scaling, and then you can change this to, you know, whatever height you want. You want to create a little ring, a bracelet. You want to create a 100mm section, you know, whatever you want. All right, that's it. Thank you for joining in. I will see you guys next week. I am going, of course, I'm playing with my hair, so I mess it up. I am going to go load the printers and get a few of these printing and see how it works out. I think I'm going to start with the NAR one because that just looks cool. That's just neat. So, you guys have a great day. Thank you for joining in. I'll see you guys later.